So.
Oh, good. Just roll it back real quick to the first slide, just so people can see what we're on. You lucky people who are watching the recording, you get to skip all of the stuff that isn't actually content. Okay, now roll back to slide 18. Okay. All right, so dependency analysis and then stupid compiler tricks. And really, I'm splitting the compiler tricks part into two sections. Tricks the compiler plays, which is actually much of that part, and then tricks that you can play with the compiler. Okay, next slide. Okay, so dependency analysis. We're on slide 20. So what does that mean? So the rule we learned last time was if two things were independent, that meant that each of them does not need the other in order to be able to do its work, right? So when we were looking at Z is assigned A times B plus C times D, whoever's doing that, there you're fine. All right. When we were looking at that, the A times B was independent of the C times D, yeah? They had nothing to do with one another, and so if they were independent, the order in which you did them didn't matter. Excuse me, and if the order didn't matter, one of the possible orders was do them at the same time. So things that are independent can happen at the same time. Is that good or bad? Please mute yourself on the phone bridge. Anyway, so it's good because doing things at the same time means that we have less to worry about in terms of how much time we're going to consume. Okay? So in dependency analysis, we're looking at how the different parts of the program affect one another and which bits require other bits in order to be able to move forward. So I may need this result from over here in order to advance to that result over there. Okay? And we generally split dependencies into two flavors. Control dependencies, which govern how different sequences of instructions affect each other, and data dependencies, which govern how different pieces of data affect each other. Okay? Let's go on to the next one, 21. So, thinking about the flow of a program, right? There's this flow of control associated with any program, right? So I'm chugging along through these statements, and then I come to a loop, and I go round and round for a while, or I'll come to an if block, and that'll make me choose between some options, or I'll go jump to another routine somewhere and do some work over there, and then come back. It's already on minimum volume. Yeah. The only thing I could do is hang up, and that would be counterproductive. Okay. So this flow of control, there's lots of different possibilities that can affect how that flow has to occur, but there's also typically a lot of freedom for, again, the order in which things happen. So understanding the dependencies in a piece of code helps you to parallelize that piece of code. Okay, next slide, 22. All right, so here's an example. I'm going to skip to 23, actually, because we're mostly C programmers around here. But folks at home, you can look at C or Fortran. They're pretty similar. So here I've got an assignment of y, and then I check the value of x, and if x has a particular value, then I do one thing, and if not, then it has another. Then I do another thing. In particular here, if x is non-zero, then I set y equal to 1 over x, but if x is 0, then I don't change the value of y. So you'll notice I really can't figure out the value of y from this block of code unless I've already looked at the value of x. Okay? So what that means is if I'm advancing through the code, I have to stop here and find out what is the value of x, and in particular, is it 0 or not? Okay, next slide, 24. So a loop carried dependency. Now these ones are much more prevalent and exciting. So notice in my loop, look at the red bits in my loop. A of I is assigned A of I minus 1 plus something else that doesn't really matter very much. So when I'm working on calculating the value for A of 2, what must I already have? A of 1. When I'm working on the value of A of 3, what must I already have? A of 2. If I'm working on the value of A of 4, what must I already have? A of 3. Yeah, A of... I don't remember what I was on, but A of I minus 1. Okay. So, given that, how straightforward is it to parallelize this loop?
It's not, but couldn't you pipeline that very well?
So, can you pipeline that? I suspect that the answer is it's difficult if not impossible. I don't know that for a fact. The reason I suspect that is that typically you won't be all the way through the stages of the pipeline on the previous iteration before you need the value in the current iteration. That would be my concern. Do what?
You can forward them.
Forward what?
All the values. You don't have to go to the end of the certain part of the pipeline before you can use it in the next section. So as soon as you're done calculating your value